Hello and welcome to another lecture for my SeminaR series for experimental methods. That's PSYC 440-640, which I'm teaching in spring of 2016 here at North Dakota State University. The goal of today's little mini lecture is just to review a bit from the last lecture on R and talk a little bit about how to do some basic graphing in R, and also introduce a package called Rcommander, which makes a lot of the statistics that many of us like to do frequently rather easy. So again, this is just an introduction to Rcommander and simple graphing in R. As I said, we'll do a bit of a review. We'll talk about some tricks for getting help in R. I'll introduce Rcommander and I'll talk a little bit about graphing. So here's the review. If you've seen the previous video, you've probably been thinking a little bit about R. Here are a couple points that I covered last time. If you remember this stuff very well, you can even skip ahead a bit, I suppose. Assuming you haven't skipped ahead, one thing we do in R is we often want to specify our working directory, our place where we're going to put data, output from analyses, etc. If you don't know what your working directory is, you can type get wd for get working directory with open closed parentheses. That'll tell you what directory is set for your default working directory, and there are plenty of ways you can change that. There's a pull down menu in the little R console, or you can type set working directory and then specify a path that you want to use. As I said last time, it's nice to keep all the material, or all the different objects, I should say, for a particular project in one working directory, so you don't get confused if you're switching back and forth between different types of analyses at different time points. Another thing I talked about last time is the concept of the library. The library is just the list of all the packages that you've downloaded, and these will usually be not be located in your working directory. They'll be located in a separate directory that R manages for you, unless you really want to move things to your working directory, which you almost certainly don't. You want to know all the packages in your library. You can just type library with open and closed parentheses, and it'll get a list of all the packages that you've downloaded from the CRAN. Now, when you first got R, you got a lot of packages along with it. Down the line, as you're doing more specialized work, you're likely to download further packages that you'll use. Now, packages are just sets of different functions, operations that we can apply to data, or we can use to create output. You want to install a package, that is to say, if you want to put it in your library, you can type install.packages and then name the package, or just use the menu system in the console, which is probably a little bit easier, especially if you don't know off the top of your head what the name of a package is. That'll download the package and put it in your directory. You can find extensive documentation on different packages on the CRAN website, and many of the really fascinating statisticians and researchers who develop packages for R will have their own personal blogs where they'll describe how their new package works and how you can get it. Now, all packages have, or not all I suppose, but many packages have dependencies. That is, other packages that that particular package needs. Now, the good news is, normally, and this is not always the case, but normally if you install a package, it'll install for you, or it'll grab for you all the dependencies that it needs. There are probably some cases in which that's not true, and if we come across any, I'll try and make sure that you know that, so you know how to get those pieces. Now, if you have a package in your library and you actually want to use it, you have to type the command library and then in open and closed parentheses type the name of the package. This will attach your package in your library. I like to think of this as getting the book down off the shelf. If the library is the set of shelves with all the books, and the books are all the packages, but you want to use a particular book, you have to pull it down off the shelf. You have to attach it. And just a quick note here, notice there are no open and closed quotes around the name of the package. I don't know why that is. There are lots of places in R where there are these funny kind of grammatical rules. It's one of the reasons why serious programmers, I think, don't like R, because it's not entirely consistent. So here you go, here's an example of that. By the way, if you have a bunch of packages already installed and attached and you're not exactly sure what they all are, you can type search open close parentheses and it'll list all the packages that are currently attached and also all the objects, that is variables and data frames and models that you've created in your analysis. So here's some stuff that we didn't cover last time. One thing is I didn't really talk too much about the workspace. The workspace is just the name for all the packages and objects that you're working with. Normally you have a reference for each one of them when you start a new session. If you want, you can save an image. For instance, if I want to have a workspace where I'm working on stuff related to learning Rcommander, I could save an image once I'm done with all the fiddling around I'm doing and call it learning Rcommander. You can do that through the code here, obviously, or once again, this is something you can pretty easily access through the menus in the console. It'll save everything that you've been doing and kind of create a history of all the work that you've done. Later on, you can double click on that workspace and load it fairly easily to run. Now I should say right here, this used to be very easy to do on my last computer, which was running Windows 8, and I have a new, well, I've got the same computer, but I've got Windows 10 installed currently, and I tried to do this the other day and it didn't work. So I'm not sure if that's a Windows problem or if something in the most recent version of R that I downloaded has changed, but the ease of just being able to double click on the icon for a workspace and get everything to pop up is no longer there, or at least if it's working, it's no longer working easily. Not a big deal though, because it's easy, of course, to open up R and then load a workspace if you really want to. A few points about getting help. Well, there are lots of menus. There are menus in the console where you can get lots of information about different packages, frequently asked questions, manuals, etc. There's a kind of a basic search function. Most menu items call up functions for you, so as you're using the menu in the little R console, just pay attention to the commands that are going on in the background, and that's just a simple way to learn. Much like if you're working in SPSS and you, rather than running commands through the menus, you paste out the syntax to the syntax window and then look at it. You can learn kind of the nuts and bolts of how R, or SPSS for that matter, does what it does. If you want to look up help on a function, you can just type help and in open and close parentheses and open and close quotes type the name of the function. It'll get any help information that's there for that particular function. If you think that there's if you think that there's a function out there in a package that ought to handle a particular thing you want to do, you can type help.search and then type the name of a subject, like for instance help.search open close parentheses open close quotes data entry, and if there is a tag somewhere for a function that does data entry, you'll get some help information about this, about which function it's in and which package that function is in. A note here, I've tried this a couple different times. It doesn't always work. The help and support for R is much more spotty than the help and support for some other stats programs like SPSS that you're probably more familiar with, but it's worth trying. If you think you need to do something like run a regression, do an ANOVA, and you're not exactly sure how to do it, you'd like to learn more, help.search open close parentheses open close quotes ANOVA will give you likely some information that could be helpful. Similarly, if you're looking for a package, you think there's a package out there and you want to find it, you can type find open and close parentheses open close quotes function, like find me a package that does a function to do with regression, to do with ANOVA. Again, this sometimes works, sometimes it doesn't work. The searching isn't perfect, but it's one way. If you have an idea when you're doing analyses that you want to be able to do a particular function, you just don't know where that function lives, what package is it in, this is one way to try and find it. To be honest though, I rarely do this. Often I just go out to Google and I look there because many of the packages that I've ever used and the functions contained therein I've learned about by reading people's blogs or even just poking around on the CRAN website. So I rarely find myself in a situation where I'm kind of doing my searching from within R, although of course you could if you really wanted to. You could look up a function that takes a particular argument. Now an argument is just an element within a function that tells the function exactly what to do or how to do it. There's an interesting function called apropos. So you can type apropos and insert a name of an argument, and it'll look for a function that works with that particular argument. So again, if you know that you want to do something related to a linear model, now that might be an argument within a function is within a package, you could type apropos, open close parentheses, open close quotes, the argument, linear or linear model, and see if anything pops up that way. R can also give you some examples of functions. So for instance, there's a function called lm for linear model. If you'd like to know how lm works, the easiest thing to do is to type example, open close parentheses, lm, and you'll get an example of linear model. R will pull up some data, it will pull up a set of analyses, and you can kind of poke through the output to see kind of roughly what LM does. This is actually very useful. Many of the functions, not all, but many of them have pretty good examples kind of built into them. So if you're unsure how to use them, it is kind of handy sometimes just to see if there's a good example. Demo works in a similar way, but it's not quite so, there's not quite such extensive support for different functions. There are some examples of functions where there are nice demos which are basically just expanded functions with more cool stuff that R can do. That's not one that I've used as much. I should say it's not a function I've used as much. Example is a function which can be rather handy. So those were all some ways to get some help in R and to kind of navigate around R in a very kind of rudimentary sense, just working with the console. I'd like to move on now and talk a little bit about Rcommander, because Rcommander is a really cool package which has a lot of functionality. Many of them are things that you might want to do if you were working with some of the statistical analyses that you probably are doing if you're in psychology or other behavioral or social sciences. Rcommander is a GUI, graphic user interface for R, makes R easier to use, at least for some of the applications that we're kind of familiar with. It was created by a guy named John Fox, who is at McMaster University. He's a sociologist, and as far as I can tell, kind of a hardcore stats guy. He literally wrote the book, or a book, on applied regression analysis and generalized linear models. It's currently in its 3rd edition. I can see my copy on my shelf over across the room from me. I haven't read it yet, but I'm looking forward to, because he, like a handful of other people who I'm trying to read up on, have these really clever ways of taking concepts from regression and working them in some interesting ways. And it's just some fascinating stuff. I really like his work, and I'm really impressed with Rcommander. It's really, really cool. Rcommander is available as a package from the CRAN. Like all the other stuff that has to do with R, it's free. It's a really big package in the sense that it has a lot of dependencies associated with it. So if we were going to get started with R, one way we could get started with R and Rcommander, one thing we could do is imagine a simple example. Imagine you're a school psychologist and you're studying reading comprehension. You have some predictor variables that include a pre-training score that each child in a particular sample has, how good they are at their kind of early reading skills, and then a group variable to indicate which group they're in, different training groups to train different types of reading skills. Then you have some sort of outcome variable, which is just a post-training score. They're clearly children's pre-training level of ability, and which group they're in ought to be somehow, hopefully, predictive of their post-training score. I'm going to put on Blackboard for my class a copy of the comma-separated values file, just a basic data file for reading comprehension, and you can download it and play along with me. So when you're ready, download that file. And when you're ready, install Rcommander. Now this is as easy to do as typing install.packages, open close parentheses, open close quotes, Rcommander, abbreviated as you see there, or you can navigate through the console menu to get the package. It's not hard to find. It'll take a little while to download because of all those dependencies. Not a very long time, but longer than most other packages in R. Once you've downloaded it, you have to attach it. So just do library, open close parentheses. Notice no open close quotes for some reason. Rcommander. This will attach the package and all its dependencies and open up the Rcommander GUI. You need to do this every time you start a new session, but again, it's not at all hard to do. So just to give you an example of what that looks like, this is the regular old console for R. This is what you get when you download R initially. You can see I've got the 64-bit version going here, though it works about the same or looks about the same in the 32-bit version. You can see here I've typed in library Rcommander to attach the library or attach Rcommander and open it up because I've already downloaded it. Once I do that, essentially what Rcommander does is it opens up another console on top of the little R console, and this one is the Rcommander console or GUI, and as you can see here, it's quite a bit more sophisticated. It's got some menus that look a little bit familiar to you probably from things like SPSS, and you can see there's some basic stuff that you can do there. Now, if we are going to use the example and get started, one of the first things we want to do is figure out what working directory we're using. Just as I talked about before, you can use getwd to figure out what the working directory is set as for your default, and then you can set it using this command here or by navigating through the menus of either the R console or the Rcommander sort of. So here you can see I'm working in Rcommander and I've just decided to change working directory, and I've got a directory and a set of subdirectories, one of which I'm calling Reading Comprehension, so I can work in there and all the stuff that I do gets left there. And as I said before, I think it's usually a good idea to have a separate directory for each project that you do. Rcommander helps us set our working directory. If we use the menu system, essentially what Rcommander does is it writes the command for us, and if you look closely at the console on the Rcommander GUI, you can see the command written there for you as you use the menus. And like I mentioned before, this is just a nice way to learn a little bit about how R works. So you can see here also a little bit about the basic grammar of R. Most of the time when you're working with R, you have a function, you have an open close parentheses, and then some sort of an argument. In this case, the argument, encased in quotes for some reason, is the directory, the path to the directory that you want to use. So, one thing we probably want to do now that we've set a working directory is we want to actually get that data. Importing data is pretty easy to do just in R, but it's a lot easier to do in Rcommander. Rcommander can read different types of files, including those from statistics programs like SPSS. It can also read text files like tab delimited or CSV files, so it's pretty easy to work with. Here you can see an image of me working through the menus in Rcommander to import some data. I'm just saying data, import data from a text file because that's what a CSV file is, but I could also import from SPSS and SAS and Minitab and Stata. So if you're someone who uses one of these other stats programs, you can actually use R and especially Rcommander to kind of work back and forth relatively easily. When I click on the button there, I get a couple menus that open, or a couple dialog boxes that open up for me. You can see one of them here is asking me to give a name for that new data set. I'm just calling it reading or ReadComp. You can see here I'm telling Rcommander that in my CSV file, commas are used to separate values. You might have a tab delimited text file, in which case tabs would be used. You should have a sense of how that works based on the file you're trying to import from. Once I hit OK, another dialog box opens up and I have to navigate to wherever that CSV file is. And you can see I've highlighted it and hit open. Okay, and you can see what happens now is that Rcommander writes a command for us, or uses a function to create a command. That command creates an object. The object is ReadComp. That I specified as the name for the data frame in the menu before. A data frame is just a matrix that is kind of familiar to us from our stats work in other programs. It's a matrix where columns are variables and rows are cases in almost all instances. The basic grammar here you can see is that ReadComp gets read table and then this long set of arguments that follow after it within parentheses. There's the path to the file. There's an argument about whether or not there are header information in our file. There are variable names in the header. We have to tell R what the separator is. We have to tell R how to handle missing values, how to handle decimal points, and so on and so on. So again, basic grammar here, just object gets function and then a set of arguments. And the nice thing about working with Rcommander is it handles working out these different arguments for us. If you were typing this out and you made an error, a syntax error in typing, this function wouldn't work. So one of the things that's really nice about working with Rcommander is it just decreases the number of errors you make, and that's of course usually a good thing. Can't figure out how to use an argument or a function? Again, you can check the help file. So if you weren't really sure how read table worked, you could type help read table, or interestingly just question mark read table, and you get some basic information about how this function works. So here you see again kind of a repeat from the previous slide, the name of the object. You can see some information about the various arguments, like the location of the data file, whether there or not there are variable names in the header, what the separator is, how to handle missing values, how to handle decimal points, and so on and so on. Interestingly, there are a lot of other arguments for this function. Those are the ones we need right now. And again, thankfully, Rcommander takes care of a lot of this stuff for us. Okay, so once we do all this, we can take a look at our data set here. Again, you can see in the background the script the R is written for us. You can see the output from those functions. And you can see over here what looks like a kind of a familiar data frame from a lot of our statistical analyses. Different subjects in different rows, different variables in different columns. So very handy, very easy to use. Keeping track of objects in workspaces, I guess I should say objects are things like data frames, variables that you create, models that you create, etc. Depending on how much you're working within a particular session, you might actually create a lot of different objects. If you lose track of them, you can type ls open close parentheses and it'll give you a list of the objects in your workspace, and you can actually remove them, rm, and then just the name of the object you want to remove if you need to do a little bit of house cleaning. I'll have to double check, but I'm pretty sure Rcommander has a menus way of accessing these same commands as well, just to kind of keep track of what all is in your workspace that you're working with. And Rcommander makes it pretty easy to view or edit data frames. You can either just click through the menus to find a data frame, or you can type this command if you want, names, open close parentheses, and data frame. They'll just give you the names of all the variables in a particular data frame. So once again, you can use the commands yourself, just typing them into the console, or you can click around the menus of Rcommander and it'll be able to do it for you. Rcommander and R give you a lot of ways to edit data in data frames and other objects. There are ways to add variables and remove variables and change values, etc., etc., etc. To be honest, I rarely use any of this stuff. Almost all the work that I do on my data to kind of prepare it, to clean it, etc., I do in Excel, or less frequently in SPSS. I find it easier to merge data files and remove odd and outlying cases and make sure all my variable names are correct, make sure I don't have any missing values, working in Excel, which is just kind of an easy and flexible and relatively forgiving environment. Then I save a copy of, let's say, my Excel worksheet or workbook, and I'll save the data separately into a tab delimited text file or a CSV text file, and then I'll open that on R, and that way I've got my original copy safely out of the reach of R in its original Excel form, and I've got this text file that I can screw around with in R, and that's usually a lot easier for me to work with. By the way, one of the things I really like about Rcommander is graphing, so I'll talk about that now. Rcommander has some very fast, very flexible, and rather powerful approaches to graphing. So for instance, in our example, you could try to create a scatter plot of the pre-treatment or pre-training, I should say, scores against post-training scores for the members of each training group. So is there a different relationship between these two variables and each level of this other variable? Rcommander makes graphing pretty easy. Again, there are lots of different options that you can use. There are different functions you can use to create graphs. Most of those functions take an enormous number of different arguments. One of the things I like about Rcommander is it handles a lot of that stuff for us. So by clicking around for a scatter plot, as you saw on the previous slide, you could get Rcommander to write the following command for you. Scatter plot post 1 by pre1 / group regression lines, regression line based on a linear model, a series of arguments about the types of graphs options that you want. So the kind of the basic syntax here is that the variable as a function of, that's what the tilde is, some other variable, by, in this case, yet another variable. So post-training as a function of pre-training by group would be the basic grammar, and then I've written here some of the various arguments that the scatter plot function can take. And as was the case with some of the earlier functions we looked at, there are actually a lot of arguments that can be made here. Happily, Rcommander handles a lot of that stuff for us. And the output we get is pretty cool. So this is kind of nice. We we see here our different groups for our different types of training, and we see the relationship between pre-treatment or pre-training ability and post-training ability in each one. The relationship looks like there's pretty good homogeneity of regression slopes. So if we were treating this as an ANCOVA and saying, like, is there a treatment effect of training once we've covaried pre-training ability, we might be able to say we've satisfied that assumption of ANCOVA. Pretty cool. Rcommander can save graphs as PDF files or as image files like PNG files. Again, this is fairly easy to do within Rcommander. It's a little bit harder just to type out all the commands yourself. Here's an example where we're creating a file name, and I'm just calling it here 2dgraph.png with these particular sizes and resolutions, etc. Once you get handy with graphing in R, you can actually do a lot, and you can make some really nice looking graphs in R. I'm not exactly there yet, so I often default to using Rcommander just because it's a little bit easier for me. So some stuff to practice on your own. Use Rcommander to try making some box plots and some bar charts. Try making some 2D and 3D scatter plots, and just pay attention to the syntax of the various commands that Rcommander writes for you. See if you can decode the various functions and arguments in each of these commands. I'm especially fond of the 3D scatter plots that Rcommander does, just because these are hard to do in SPSS, which is where I do most of my stats otherwise. Okay, finishing up. If you want to save the workplace, it's really easy within Rcommander, just using the menus in the console, or if you wanted to, you could type the command save.image and then provide the path to where you want to save an image of your workspace. Just a few more tricks about graphing. What if you wanted to do graphing without Rcommander? I'm not sure at this point why you would, but The truth is R has a lot of different options. I'll try and get to some of these in future SeminaR lectures. Some of these involve functions from the base packages, others involve specialized functions that you can get yourself. I'll talk about these a little bit later. But okay, let's say you want to start from the beginning working in the regular R console, not using Rcommander, and just mess around with a data set. You could begin by first, of course, setting your working directory. You could use the console for this, or you could type these commands as we talked about before. You could load some data. Here again, we have got the read table function, so our object ReadComp gets the table that is specified for reading comprehension .csv with a bunch of different arguments about the structure of the data. The only reason I'm repeating this, by the way, is just to make a quick point that I think I missed earlier, which is that once you've set a working directory, you don't need the whole path name to find your file. So you don't need to type all the backslashes to navigate through your hard drive to just where that file is, which is actually kind of handy. So if you had set a working directory for a place where you're going to put all your data, and if that working directory contained your file, in this case it's comprehension.csv, you could very quickly read it in to an object, a data frame like this, called ReadComp in this case. Once you had your data, you could look at it to make sure it's okay. Here are just a few tricks that I didn't mention earlier on. So you could just type in FileName ReadCompData to look at all the data on the screen. You could, if it's a big data file and you don't want to look at all of it, you could just type head ReadCompData, which would give you just the top 6 cases and variables, or tail, which would give you just the bottom 6 cases or variables. You could also look at the data just to make sure it looks okay. For instance, typing names ReadCompData would give you the variable names in your data frame. Summary ReadCompData would give you some descriptive statistics for the variables in your data frame. This is actually a handy one, just again to kind of get a sense of what your data looks like, maybe give you a hint as to whether or not there are some outlying values. So once we have a data frame in our workspace that we're going to work with, we actually have to attach the variables in that data frame that we want to perform different functions on. You know, right now our workspace has an object, the data frame, but it isn't attached. And R can't do a lot with the actual variables in that data frame. Some functions do work. For instance, the summary function, which I just showed on the previous slide, do work, but most can't. So if you were to type, you know, a function to make a linear model out of the variables in your data set, you get an error returned to you. This is just the way R works. It's very conservative about getting into data and messing around with variables. You can get around this by saying attach and then the name of your data frame. So attach ReadCompData is going to attach the data frame so that now other functions can use all the variables in it. A quick note, advanced users of R don't like the attach function usually because it can create problems where if you attach different objects which have variables which have perhaps the same name, like you've got two different data frames, they both contain a variable called anxiety, and you attach both of those data frames, R can get confused as to which anxiety you're referring to when you say, you know, make a linear model of anxiety. So there are actually some ways to get around or avoid using the attach function. I'm going to not talk about those right now. I'll get to them in a future lecture. Okay, so now you say, all right, I've gone through all this work. I've loaded a file and kind of read it into a data frame. I've attached that data frame. I've looked at different elements of it. Now, just please let me make a simple scatter plot. And that's actually not that hard. You could, for instance, use the function plot pre, post, and give some arguments here like I've noted. And this would give you a basic scatter plot. The syntax here to pay attention to is that plot asks for two variables, pre1 and post1 in this case, and then has some additional arguments which are essentially options for labeling. I've kind of highlighted or explained some of them here. So you can give, you can put a label on the graph, You can label the x-axis and the y-axis, and there are actually a lot of other things you can do, but these are the most obvious ones that you would probably want to do. Once you've got your scatter plot, you can add a line to it. The function here is abline, or abline, I guess. Here we're actually using two functions because we're saying add a line, but that line is going to be based on a linear model, that's the lm function, of post1 as a function of pre1. So again, the basic syntax here is that we're taking a line based on a linear model of post1 as a function of, that's the tilde, of another variable pre1. And the AB in AB line refers to the intercept and the slope of the line, which can be any values we want. So for instance, we could do AB line and just give it some values, which would then draw the line that we wanted. Or in this case, we're saying get those values, the A and the B, the intercept and the slope, from this linear model, which is kind of cool. There's a lot of flexibility in drawing lines in your scatter plot, which can be useful if you're comparing a compact model to an augmented model and so on. So making a scatter plot of two variables is cool. It's interesting. What if you wanted to make a scatter plot of three variables, something that looks like it occurs in 3D space? Well, one way you can do that is by getting a package called scatterplot3d, which does basically what you guessed from the name. So as you would do with other packages, you have to install it. So you do install.packages, and in this case, the name would be scatterplot3d. Or you could just use the menu in the console to go find it. Once you've got scatterplot3d in your library, you have to use the function library scatterplot3d to kind of pull it down off the shelf so that you can use it. And then you can type in the function scatterplot3d and give it your three variables. In this case, pre1, post1, and pre2. So the basic syntax here is you're just using the function scatterplot3d and you're giving it three arguments, one for the x-axis variable, one for the y-axis variable, and one for the z-axis variable. The only tricky thing here is that the way scatterplot3d is set up, the x and y axes lie on a plane and the z-axis rises up from that plane, which is just the way it is set up. Another way you could do some 3D graphing in R is to use the RGL package. Here again, we're just going to install the package or use the menus in the console. One weird thing is that this package is a dependency for Rcommander, so it's possible you'll get a message saying you've already installed this package. If you have, or even if you do get that message, type the function library RGL to pull RGL down off the shelf, so to speak, and then plot3d is the function within the package RGL, which allows you to do some 3D plotting. Here the basic syntax is, again, the x-axis variable, the y-axis variable, and the z-axis variable. Here you can take, this function takes some additional arguments. You can specify the space. You can specify different sizes of dots, and also, and this is cool and you should really see it yourself, you can spin the graph in 3D space, which is pretty cool to look at. So I haven't shown pictures of these in this little web video, but you should really try it yourself, see how that works. Alright, so if you're just finishing up now, you've done some graphing in Rcommander, you've done some graphing outside of Rcommander. Let's say you want to finish up and end your session. You can look at the objects you've created using objects, open close parentheses. You can detach ReadComp, your data frame, from use so that the R's functions can no longer get in and easily work with the variables in that data frame. You can even, if you want, do rm open close parentheses, which will remove all the objects that you've created. So that's a fairly powerful tool. You want to be a little bit careful about using that. Okay, this has been a bit of a scattered lecture, not my best probably, but I hope it gave you a little bit of a feel for working in R, and especially using Rcommander, which is a really powerful package, or really set of packages to use. Also some tricks you can do outside of Rcommander, especially for graphing. I'll be back in future SeminaR videos to talk a little bit more about how we can do some other cool things, like some basic regression analyses in R. So see you then, and in the meantime, thanks, as I always say, thanks for your attention. Bye-bye.